formula tool to do the same thing, to find the sine, the length of a side of a triangle that is missing, and these apply to any triangle once again. Okay, so let's begin by just a quick description of what these laws do. So I should say, if we know, let me describe them like this. One, if we know two sides and the angle in a triangle, or so I'm going to say, so that's one thing we can use, one occasion when we can use the law of cosines to find the measure of angles and sides in a triangle. Or second, if we know the three sides, triangle, and then we can use the following formulas. So or angle. Okay, so under these two occasions, these formulas are useful. I think I should draw a picture to augment these formulas, so I'm going to do that here. So we have, suppose we have this kind of triangle, like that, and like that. And of course, so this, let's label the side that is opposite this angle, lowercase a, the side that is opposite this angle, lowercase b, and this side C. Given that, then the law of sines will be as follows. The law of cosines, sorry. So a squared equals b squared plus c squared minus 2bc cosine of a. So b squared equals a squared plus c squared minus 2ac cosine of b squared plus b squared minus 2ab cosine of c. So these three formulas for the law of cosines are pretty easy to remember. It's just that on the left we have the measure of each side, a squared, b squared, c squared, and of course, once we get this quantity, we'll take the square root of it, and we accept the positive answer for the length of that side. But each formula, if you carefully look at it, is equal to the sums of squares of the other two sides minus twice the known sides, the product of the measure of two sides, times the cosine of the angle opposite to the side we're looking for. Okay, they're all like that. So cosine of B is the angle opposite of the side we're finding, and cosine of C is the angle that's cosine of the angle that is opposite to the side we're finding the length of. And the other terms are simply the squares of the sides we know minus twice their product. They're all like that. Okay, so let's apply these in an example or two. So here, there's a picture that comes with this question, and I'm going to draw it here, right there. I think that should be enough space. That's angle C, angle A, angle B. We know that that angle A, we are given that as 108 degrees. We also know that the measure of this side, AB, is 18, and this measure is 15, and we are asked to find let's see, and this side, x. So this side is not known, or this though this is not correct, so we're not looking for the angle. We're just looking for that's, I think, actually belongs to maybe one of the other examples, not this example though. So this is what we want to find, the side x. Okay, so compare that, what we're asked to find, with these formulas. So do you see which one you have to use? The first one, right? The first one can help us find x. Instead of a squared, we're going to have x squared. And then b squared would be, b squared plus c squared would be 18 squared plus 15 squared minus 2 times 15 times 18 times cosine of 108 degrees. So based on that, let's write this down. We're going to say x squared is equal to 15 squared plus, I'm just applying this formula, plus 18 squared minus twice 15 times 18 times cosine of 108 degrees. Like that. So I was just calculating these. So 15 squared, 225. I do have these numbers, so I'm going to use them as I have. Please double check these numbers. I think they are correct. So 225, that's that. Plus 18 squared is 324 minus all of that 540 times cosine of 108 degrees. I want to double check my number on that. So cosine of 108, and we have that. 0.37. Let's see. Oh, I need to change this to degrees. So it was set to radians, so I changed it to degrees. So now cosine of 108 is that number. Okay, so let me add that. And so minus point. So we're multiplying a minus by a minus, which means we were going to get a positive. And I'll round that 6 to 7 because there's a 9 after it. So we'll have x squared equals 225 plus 324 plus 166. That's multiplying these two. Minus 540 times minus 0.309017. It is positive 166.869. Okay, so x squared is equal to 715.869. X is equal to, by square root property, right? We learned this in pre-calculus 1, math 126. So we're going to have plus or minus 26.76, but the measure of a side of an angle cannot be negative. So we're going to just accept the positive answer. So x equals 26.76. So this is by a square root property. I just want to remind you from previous classes by the square root property. Okay, so the measure of that side is 26.76 units. Could be meters, feet, or inches, or anything like that. Okay, let's do another example. In this example, we want to solve the triangle ABC. Previously, last time, we talked about what this means, right? When we say solve a triangle, we mean find the measure of all of its angles and all of its three sides. Okay, and this is the figure we are given. And so we have like that. So all of this information is given. So what we're asked to find when they say solve the triangle, so since all the three sides are given, then basically what we're asked to find is the measure of angle A, the measure of angle C, and the measure of angle B. Okay, those are the quantities we need to find. Okay, so law of cosines can easily be used to find each of these angles. We actually need to find two of these, right, using the law of cosines. Once we know any two angles, we can easily find the third one by adding the other two angles and subtracting them from 180. I think since you already know the formulas for the law of cosines and you know how easily they can be applied, I would encourage you to pause the video at this time, use the law of cosines to find these measures, these angles, and then come back to the video and see what my solution is. Okay, so I'm assuming you've done that, and now you have your solutions, and you're ready to compare them with mine. Okay, so I will start by finding the angle A. Angle A is opposite side A, so this will be A squared equals B squared plus C squared minus twice BC cosine of A. All right, that's the formula. So that means cosine of A, if we solve this equation for cosine of A, we're going to have A squared, right, minus B squared minus C squared, all of that, divided by minus 2BC, minus 2BC. Okay, so let's plug in. Then we have cosine of A squared, that would be 4T squared, minus B squared, that would be the side opposite angle B, so 12 squared, minus C squared. C would be the side opposite angle C, so 44 squared, divided by minus twice B, that would be 12, times C, that would be 44. Okay, so therefore cosine of A would be equal to 16, that's 40 squared is 1600, minus 144, minus 1936, divided by minus 1056, which is minus 2 times 12 times 44. So after that, we have cosine of A equals minus 480. That's all of that. 1600 minus this minus that. So we get minus 480 over minus 1056. And this is minus divided by minus is a positive quantity. 0.454545, and it's repeating that. So I'm going to stop there. But this isn't the angle A, right? This is cosine of A is that. So we need to find the angle A. So the angle A is equal to, right? Angle A is equal to, do you know how to find this? Inverse of cosine, right? Inverse cosine. So inverse cosine of A. So inverse cosine of this quantity, 0.454545, and so on. 45. Okay. So using the calculator, the measure of angle A is equal to 62.96 degrees, or roughly we can say angle A is equal to 63 degrees. So something like that. Okay, that's the measure of angle A. For angle B, we use for this angle, we're going to use this formula. B squared equals A squared plus C squared minus 2AC cosine of B. Right? So let's do that. So this is, so let me organize this a little bit. Here we found angle A. Here we're going to find angle B. And that is, we have B squared equals A squared plus C squared minus 2AC cosine of B, right? So cosine of B, or beta, cosine of B, let's say, is equal to B squared minus A squared minus C squared, all of that divided by minus 2AC, right? I moved all of this to one side, minus A squared minus C squared, and then divided that side, left side, by minus 2AC. That's all I did. So we can plug in cosine of B is equal to 12 squared minus 40 squared minus 44 squared divided by minus 2 times 40 times 44. Okay, so that's A times C. That's A, which is 40, times C, which is 44. Not minus 44, but 44. Okay. Okay, so once again, after simplifying, we have cosine of B, or B equals 144 minus 1600 minus 1936 divided by minus 3520, and then cosine of B is equal to minus 3,392 divided by minus 3,520. And I'm running out of space here, so let me move in here like that. And so we have cosine of B is equal to 0.963636. So notice in the middle of my calculations, again, I'm keeping at least 5-6 decimal places. Okay, that's just so that I can be as close as I can to the actual value at the end. So this is cosine of B. It's not the measure of angle B, right? So we know how to find the angle B by taking the inverse cosine of this quantity. So inverse cosine of that quantity is equal to B. So angle B is equal to the inverse cosine of this quantity. So angle B is equal to, use your calculator with this. So I'm going to show you here. I hope you can see it in the video. So I have a cosine button here. Right on top of it, in purple or blue, is inverse cosine. To activate that button, I'm going to need to use this second button before that. So second, right now I have the inverse cosine activated, and I'm going to put in this quantity, 0.963636, and then enter, and you get 15.4988. I'm going to round that to 15.5 degrees. So we have the angle A figured here, and angle B figured out here. So we can easily find the measure of angle C. So, and that's, let me box that. In addition to that, so then angle C is the easiest of them all. We simply say 180 degrees minus 63 plus 15.5, and we get 101.5 degrees, and that is angle C. Oops, let me move this into the screen. So there. Angle A is 63 degrees, angle B is 15.5 degrees, and angle C is 101.5 degrees. Okay, so that's the application of the law of cosines. Let's learn, this could be optional. Again, I'm preparing these videos ahead of what the coordinator of this course is going to announce later. I'm going to call this topic optional. So if he says, let's include this on exams and homework and everything, we're going to include it. And if he says, no, let's exclude it, then we're going to exclude it. But I'm going to cover it so it's in the video, whichever way the coordinators decide to go with the setup for the homework and the exams. So this is a new way of finding out the area of a triangle. So the area of a triangle so you already know, let me draw this picture here. Suppose we have some triangle like this. And here we have the height. And we have VA. Let's call this height H, and this angle here theta. Okay, suppose we have that triangle. And so the area formula that we learned in elementary geometry in high school was like this, right? Let's just recall from high school geometry. That the area of this triangle can be written as 1/2 the base times the height. Okay, that's what we learned from high school geometry, like that. Okay, we already know this from years ago. Then, earlier in this course, maybe 2-3 sections ago, we learned a trigonometric version of this. Remember that? So also, recall from a previous section in this course, it was in chapter 6, so one of those sections we covered before. A previous section that in a trigonometric equivalent to this would be area equals 1/2 times the base times, instead of height, we can write b sine of theta, or this hypotenuse of this right triangle, if we take that. So that being the hypotenuse of this right triangle here, b sine of theta, that angle. So that's another thing we learned earlier in this course. Now, a new formula is this formula. Let me write down the formula, then I'll define what it is. So A is equal to square root of S times S minus A times S minus B times S minus C. Like that. Or maybe change the color so the square root stands out. Like that. Okay, so the question is, what is S? Because A, B, C can be taken as the measure of these sides, right? So if we call this C, and I will call this B and this C, okay? Then A, lowercase b, lowercase c are the measure of these sides. But what about S? What does that represent? So let's add where S is equal to 1/2 the perimeter of the triangle, right? A plus B plus C is the perimeter of the triangle. So S is 1/2 the perimeter of the triangle, all those three sides added to each other. So I need to also box this connected to that. Okay, and so we find the half of the perimeter of the triangle, then multiply that measure by the difference between that half, that's measure by the difference between the S and each of the sides, the lengths of each of the sides. So once again, find the half of the perimeter of the triangle for which you're finding the area. Then take that measure S, multiply it by the difference between that measure and each of the other three sides of the triangle, and take the square root of it. And that'll be the area of the triangle. Let's apply this in an example. So we are provided the lengths of this triangle. So A, we are told, is equal to 11. B, we are told, is equal to 100. And C is equal to 101. I guess I can draw, the actual problem didn't provide a graph, but maybe I can draw a graph here, a quick one. So it probably won't be to a scale, but I'll try to make it to a scale. So let's say the triangle looks something like this. So we have this. So this is going to be a very oblong triangle, right? One side is 11, the other sides are 10 times as long as this. So I will just do something like this and something like that. Okay, so A is equal to 11. B is equal to 100, and C equals to 101. Okay. All right, so the S would be half, this S would be half of the perimeter, right? So let's find that out first. We have S equals 1/2 of 11 plus 100 plus 101. So S would be equal to, what I have is 106. Right? Let's double check that because I have my, I don't know, I haven't double checked these numbers. So 11 plus 100 plus 101, that divided by 2, it's 106, so it's correct. So using that, let's find the area using that formula. So we have A, which is equal to square root of 106 times 106 minus 11 times 106 minus 100 times 106 minus 101. Okay, everything being multiplied, so we have A equaling 106. 106 minus 11, that would be 95. 106 minus 100, that is 6. 106 minus 101, that'll be 5. Right? Multiplying all of those, we have A equals square root of 30,000 or 302,100. So from this, A, take the square root, and I have 549.64. Right, so let me double check that number again. I want to double check this. So square root of that. So square root of 302,100. Yeah, 549.63, and I've rounded that 63.6 to 64 after the decimal. Okay. Okay, so this wraps up our discussion of the law of cosines, very useful formula. This, if you take this set of laws with the law of sines, these are extremely useful for finding measures of angles and sides in any triangle. Okay, I'm glad that you watched this video. When we come back next time, we will begin a new chapter. I believe it should be chapter 7, but I have to double check. But for now, have a very nice day, and I'll see you all next time.